Welcome to our new Red Book tutorial. Today, the topic is Site Preparation Works. We'll explain the most common scope of work elements in Part 1. The pricing schedule will be explained in a separate Part 2 video. Please watch to the end.
You know the scene. You are walking down the street, maybe coffee in hand, and you pass one of those massive chain link fences.
Yeah, the one's completely covered in that green privacy mesh.
Exactly. You peer through a gap in the mesh, and well, what do you actually see?
Usually just a giant, muddy, seemingly empty lot.
Right. Maybe a couple of idle bulldozers just sitting in the dirt. And you probably think it is just empty space, waiting for the real work to begin.
Which is what pretty much everyone thinks,
Yeah.
but you would be entirely wrong.
So wrong, because that muddy lot is actually a highly engineered, legally binding, and mathematically precise blank canvas. It is governed by a ruthless set of rules.
Absolutely ruthless.
Today, we are unpacking the massive, high-stakes legal and physical puzzle that happens before a single brick is ever laid on a major infrastructure project.
It is a massive undertaking.
It really is. We are doing a deep dive into document number S1.1, the Site Preparation Works specification of a FIDIC Red Book construction contract.
And, for anyone who doesn't spend their weekends buried in international construction law, the FIDIC Red Book is basically the global gold standard for complex construction contracts.
The ultimate rule book.
Exactly. It dictates exactly who is responsible for what, and critically, who absorbs the financial blow when things inevitably go wrong.
And to give you a sense of the stakes here, I want you to think about prepping for a massive dinner service at a Michelin star restaurant.
Oh, that's a great way to look at it.
Right. Because if the kitchen isn't perfectly sterilized, if the ingredients aren't verified down to the gram, and if the prep cooks haven't executed their jobs flawlessly, the actual cooking is going to be a disaster.
An absolute mess. You cannot execute a culinary masterpiece in a contaminated, disorganized kitchen.
Exactly. The permanent works of the meal rely entirely on the invisible work done hours before the first order is even fired.
That captures the essence of document S1.1 perfectly. The stated objective is to deliver a fully prepared site suitable for the subsequent execution of the permanent works.
Makes sense.
Right? The engineer acts as the employer's representative, overseeing the administration. But Section 2 of this specification, it lays down a staggering mandate.
Yeah, it really does.
It legally binds the contractor to provide all labor, materials, equipment, and temporary works. But it goes so much further than just supplying tools and people.
Oh, way further.
Mm-hmm.
Because Section 2 contains what I can only really describe as a legal trapdoor.
A very expensive trap.
Yeah. It's a catch-all clause. It literally states that any work, services, or items not expressly described in the contract documents, but which are necessary for the completion of the works, well, they must be executed by the contractor without any additional cost to the employer.
It is the exact kind of clause that forces project managers to double and triple check their insurance policies.
I bet.
The employer is essentially transferring the dire risk of the unknown directly onto the contractor's shoulders.
It feels like buying an all-inclusive vacation, And right as you're packing your bags, the travel agent casually mentions, oh, by the way, if we forgot to put your return flight on the itinerary, it is your responsibility to book it and pay for it yourself. Enjoy the beach.
That is exactly how it feels.
So I am trying to picture how a contractor practically prepares for unknown unknowns when they are bidding tens of millions of dollars on a project. How do you price a ghost?
Well, you price it by being intensely proactive, and that is the exact behavior this contract is designed to force.
Okay.
The employer's logic is basically, we are paying for your expertise, not just your manual labor. So Section 3 specifically mandates the contractor must scrutinize all documents upon receipt.
Like immediately?
Immediately. They are legally obligated to notify the engineer of any errors, omissions, or ambiguities before they even start up a single bulldozer. They have to rely on what the contract calls recognized good industry practice.
So if they are required to use recognized good industry practice, that implies the contract isn't just binding them to the literal words on the page.
Right.
It's binding them to the entire unwritten professional standard of their field. They can't just act as mindless order takers and say, well, hey, I just built what you drew.
Far from it. Let's look at a hypothetical disaster, just to illustrate that.
Okay, lay it on me.
Imagine the blueprint for the site preparation is missing a crucial retaining wall near a steep incline.
Oh, boy.
Right. Any competent geotechnical engineer looking at that site would know a retaining wall is necessary to prevent a mudslide.
So it's obvious to a professional.
Exactly. Now, if the contractor fails to catch that omission during their mandatory review and they just clear the site according to the flawed drawing and a mudslide occurs.
Let me guess. The catch-all clause kicks in.
You got it. The contractor pays for the cleanup, and they pay to build the retaining wall entirely out of their own pocket.
That is just wild. Given that massive financial sword of Damocles hanging over them, the contractor basically cannot afford to trust the existing site environment at all.
Not even a little bit.
They have to take absolute physical control from day one, which I guess explains the sheer scale of Section 4, the mobilization and site clearance.
Oh, mobilization, outlined in Section 4.1, is a monumental logistical hurdle. I mean, it isn't just dropping a portable toilet in a trailer on an empty lot.
Which is what I always pictured, honestly.
Most people do,
Yeah.
but they actually have to establish a temporary, fully functioning mini-city.
A mini-city.
Yeah. We're talking about negotiating with municipal grids to tap into power and water, setting up high-bandwidth telecommunications, installing specialized sanitation facilities,
Wow.
building temporary access roads that can handle the sheer weight of heavy machinery,
Yeah.
and securing a labyrinth of permits just to legally exist on that specific piece of land.
So they are essentially building a temporary infrastructure network just to support the people who are going to build the permanent infrastructure network.
That is exactly what it is.
And once they finally have their mini-city up and running, Sections 4.2 and 4.3 get into the physical clearing and demolition,
Right, the tearing down part.
ripping up existing vegetation, tearing down old structures, safely capping and disconnecting old, potentially dangerous utilities like live gas mains or high voltage lines.
It is highly hazardous work.
But then we hit Section 4.5, which covers ground improvement. And this is where the reality of the dirt itself comes into play.
Ground improvement is often the most volatile phase of the entire operation. I mean, the contractor is entirely responsible for identifying and excavating unsuitable or contaminated soils.
I have to pause on this because when I read the specifics of Sections 4.5.3 and 4.5.4 regarding environmental protection, I was genuinely surprised.
What surprised you?
Well, I always assumed that if a crew dug up a pocket of toxic soil, say heavy metals from an old factory, or hydrocarbons from a forgotten gas station, they just loaded it into a lined dump truck, drove it to a specialized hazardous waste landfill, and that was the end of it.
Out of sight, out of mind.
Right. But this specification heavily emphasizes treating the soil on site. Like, they can't just truck it out. They actually have to wash or stabilize the dirt right there on the lot.
Trucking it out is often the absolute last resort. And understanding why requires looking at the broader environmental calculus.
Okay, how so?
Simply loading contaminated soil into a fleet of dump trucks and driving it across a populated city introduces a massive, unacceptable level of risk.
Oh, I see.
Yeah, you have toxic dust blowing off the truck beds, the potential for a traffic accident spilling hazardous waste into a residential neighborhood or a storm drain.
You are taking a localized container problem and risking turning it into a regional ecological disaster.
Exactly. So the contract deliberately boxes them in. It demands they solve the chemical problem within the physical boundaries of the site.
That is intense.
It is. The contract insists on strict environmental protection measures to prevent cross-contamination. They know to aggressively control dust, mitigate odors, and manage runoff and leachate.
Leachate being the contaminated water that drains out of the soil when it rains, right?
Yes. Precisely. Section 4.5.4 details the treatment and remediation protocols. This can be in situ, meaning treating the soil deep underground right where it lies, or ex situ, which means excavating it but treating it elsewhere on the exact same site.
The document explicitly mentions soil washing. I was really trying to picture the mechanics of that. How do you wash dirt? Are we talking about giant washing machines for gravel?
Conceptually, yeah. Actually, soil washing is an intense mechanical and chemical process. Picture a massive industrial sorting facility temporarily erected right there on the lot.
Okay.
They feed the contaminated excavated dirt into large trommels. These are rotating cylindrical screens using high-pressure water jets and chemical surfactants to scrub the soil.
Literally scrubbing the dirt.
Literally. The goal is to separate the fine, heavily contaminated clay and silt particles from the larger, clean gravel and sand.
Oh, because the toxins cling to the finer particles?
Exactly. So the clean aggregate can be reused on site, and only the concentrated, highly toxic fine sludge has to be carefully disposed of.
That is wild. They are operating a heavy-duty chemical decontamination plant before they have even poured a single ounce of concrete for the foundation.
And if washing isn't viable, they might use soil stabilization,
How does that work?
This involves deploying massive augers to drill deep into the contaminated earth, injecting and mixing binding agents like cement or specialized polymers directly into the soil.
Oh, so it hardens.
Right. This chemically locks the toxins into a solid matrix so they cannot physically leach into the groundwater. And strict environmental permits dictate the movement, testing, and handling of every single grain of that soil.
Because, circling back to that catch-all clause we talked about, if they excavate contaminated dirt, fail to cover it properly, and a heavy rainstorm washes toxic runoff into the local municipal water supply.
The Environmental Protection Agency shuts the billion-dollar project down immediately.
And the contractor is entirely liable for the delay and the fines.
The liability is absolute.
Which means all this effort, washing soil, stabilizing toxins, moving thousands of tons of dirt, is utterly useless if it isn't done to exact geometric specifications.
Yeah, it has to be perfect.
Which brings us to the invisible mathematical framework that governs this entire operation. Let's look at sections 5 through 7.
Sure. Section 5 covers survey and setting out. This is the critical translation phase, where the two-dimensional blueprint is mapped onto the three-dimensional physical reality of the Earth.
Right.
The employer, or the engineer, provides the initial reference points and base coordinates. But crucially, the contractor must independently verify all of that survey data before they do anything.
I love this detail because it's yet another trapdoor of strict liability. The contract explicitly states that any errors in setting out the site must be rectified entirely at the contractor's cost.
Completely at their cost.
It reminds me of a bespoke tailor making you a suit. If the tailor measures your inseam wrong because they used a faulty tape measure that you handed them, but they didn't bother to verify your tape measure against a standard ruler first...
They still have to buy the ruined fabric and make you a new suit out of their own pocket.
Yes. It's wild to think about.
It's a brutal reality, but it's the core philosophy of a FIDIC contract.
Yeah.
If you build the foundational retaining wall 2 inches to the left because you didn't double-check the employer's coordinates, the entire geometry of the skyscraper going on top of it will be fundamentally compromised.
Everything is thrown off.
Exactly.
Yeah.
The contractor is paid specifically to be the expert verifier. But mathematical precision is only one pillar of this framework. Section 6 dictates health, safety, security, and environment, the HSE protocols.
Oh, yes.
The contractor has to implement RAMs, which stands for Risk Assessments and Method Statements.
I've actually seen RAMs mentioned in engineering circles. It's essentially a highly detailed document that says, here is the inherently dangerous thing we're about to do today, and here is exactly, step by step, how we are going to do it without anyone getting killed or injured.
Yes, and it is granular to the extreme. A RAMs document isn't just a generic safety poster on the wall saying, wear your hard hat. If they're moving a single piece of heavy machinery near a trench, the RAMs details the exact path of the machine, the spotters required, the soil-bearing capacity near the edge of the trench, and the emergency response procedure if the trench collapses.
Wow.
Add to that mandatory PPE usage and strict access control with fencing and security gates. And this extreme level of control feeds directly into Section 7, coordination. The contract refers to this as interface management.
Interface management. You know, in software, that's how two different programs talk to each other. How does that apply to a physical dirt lot?
Well, in construction, an interface is the physical or scheduling boundary where different teams, different scopes of work, or different contractors collide.
Okay, I can picture that.
Think of the contractor managing the site preparation not as a symphony conductor, which implies a peaceful artistic flow, but rather as an air traffic controller working at a one-runway airport where all the planes are made of concrete, steel, and heavy machinery.
Oh, man, I can see that. If one concrete truck misses its scheduling window, it blocks the steel delivery, which delays the crane operator.
Which costs tens of thousands of dollars an hour.
Exactly.
Precisely. They have to coordinate with the engineer, the employer, and entirely separate contractors hired for other phases of the project. They have to manage the geographical and temporal boundaries to avoid disrupting adjacent works, existing city operations, and third parties.
Like the general public walking right outside that green privacy mesh.
Exactly. The site must be geographically flawless, chemically neutral, and strictly secure so the next wave of workers can step in seamlessly.
So the dirt is clean, the math is perfectly verified, the site is locked down, and the air traffic control of heavy machinery is flowing smoothly.
Yes.
But because of the immense crushing legal liability we've been talking about, no employer is just going to walk onto the lot, nod, and take the contractor's word for it.
Absolutely not.
They need immutable proof. which introduces what sounds like the most tedious part of the entire specification. Section 8, the completion and handover documentation.
The paperwork mountain at this stage is absolutely staggering. The physical work might be finished, but you have to legally prove you delivered what was promised.
Right.
The contractor must verify the soil compaction, the slope stability, and the drainage performance through rigorous field and laboratory testing. They're doing things like Proctor compaction tests, taking physical core samples of the earth to a lab.
Just to prove the soil density meets the mathematical requirement to bear the weight of a high-rise.
Exactly. They aren't just saying we rolled over it a bunch of times with a heavy machine and it looks flat. They are providing certified physics data, and they have to submit what are called as-built drawings.
Meaning, here is a schematic of what we actually built in the ground, as opposed to what the original blueprint hoped we would build.
Because the earth is dynamic, Things always shift slightly from the original design. You hit a boulder, you route a pipe slightly differently. The employer needs the final, true map.
That makes total sense.
But here is an element of Section 8 that often catches people off guard. The contractor must also provide operation and maintenance manuals, O&M manuals, for any installed systems.
Okay, this is where my brain stalled out reading the spec. O&M manuals for site preparation.
Yeah.
I completely understand needing an operation manual for a complex HVAC system in a finished hospital or a high-speed elevator bank. But what on earth needs an operation manual in what is, at the end of the day, a highly prepped dirt lot?
I get it. It sounds weird.
Yeah.
It requires a shift in how you view the site. When we hear site prep, we imagine a dormant, flat patch of land.
Right.
But a highly prepped site is actually a living, active machine.
Yeah.
It often includes complex temporary or even permanent drainage networks that require specific maintenance to prevent erosion.
Oh, interesting.
It might feature deep dewatering pumps running 24 hours a day to keep the natural water table artificially depressed, so the next contractor can pour a deep concrete foundation without it immediately flooding.
Ah. So if nobody maintains those pumps according to the manual, the pumps fail, the water table rises overnight, and the newly excavated foundation turns into a swamp.
Exactly. Or consider the ground improvement we discussed earlier. If they used active soil stabilization systems or installed subterranean monitoring wells to track groundwater contamination levels over time, all of those require specific ongoing protocols.
Wow.
The permanent buildings aren't up yet, but the site is already a functioning engineered system. The employer needs the manual to know how to keep that system from basically collapsing in on itself.
That completely changes the mental image. And once all that documentation, the lab tests, the as-built drawings, the manuals is submitted, the contractor applies for a taking over certificate.
Yes.
But knowing FIDI, I assume getting that certificate doesn't mean they're fully off the hook.
You assume correctly. Section 8 details the defects notification period. This is a specified window of time after handover, often a year, sometimes longer, where the contractor remains tethered to the project.
Tethered how?
Well, if a defect is discovered during that time that was the contractor's fault, say, a section of the site unexpectedly settles 3 inches because the lab test missed a pocket of poor compaction, the contractor must mobilize their crew, come back to the site, and remedy that defect entirely at their own cost.
The ultimate accountability. They truly own the risk from the moment they read the first blueprint right through to a year after they've left the site.
They do, and this is why contract administration, which is covered in Section 9, ensures every single form, daily register, and piece of evidence is archived. Because in international construction law, if a decision or a test result isn't meticulously documented, it legally didn't happen.
Wow. Which means the next time you, the listener, are walking down the street holding your coffee and you pass one of those freshly cleared, fenced-in construction sites, do not just see empty land.
Far from it.
You are looking at a heavily engineered, legally bound, and rigorously verified foundation. You are looking at mathematically perfect coordinates, chemically washed soil, and a space that absolutely guarantees that whatever billion-dollar structure goes up next won't sink into the mud, slide down a hill, or poison the city's groundwater. It is a triumph of invisible engineering.
It is the essential mastery of the earth before the visible mastery of architecture even begins.
Archive everything, because if it isn't documented, it didn't happen. But you know, looking at how intense that human documentation process is actually makes me wonder about the future of this entire FEI framework.
How do you mean?
Well, we have spent this whole time talking about immense human liability, the contractor taking all the risk, verifying the surveys by hand, taking the fall for the catch-all clause, but we are rapidly entering an era where AI and autonomous systems are taking over these exact verification tasks.
Yes, the industry is already shifting. I mean, we have autonomous drones flying the site daily, using advanced photogrammetry to
Yeah.
build real-time topographical maps. And AI models analyzing ground-penetrating radar to flag subterranean contamination.
Right. So here is the provocative thought to leave you with. As these autonomous tools become recognized good industry practice, what happens when the algorithm is wrong?
That is a million-dollar question.
Right. If an AI model analyzes the radar and fails to flag a massive hidden pocket of toxic soil, and the contractor builds over it who bears the millions of dollars in remediation costs under that ruthless catch-all clause,
It's a huge gray area.
does the construction contractor still eat the cost because they relied on the tool? Or does the liability finally shift away from the dirt and onto the software developer who trained the AI model?
It is a profound legal battlefront that the infrastructure world is just beginning to confront. When the human expertise demanded by a traditional FIDC contract is replaced by an algorithmic output, those centuries-old definitions of liability are going to be tested in unprecedented and incredibly expensive ways.
It is going to be a fascinating collision of old-school contract law and cutting-edge tech. Definitely something to chew on the next time you see a drone hovering quietly over an empty, muddy lot.
Absolutely.
Remember, the kitchen has to be spotless before the cooking begins. Keep questioning the complex layers hidden behind the everyday world around you, and we will see you on the next deep dive.
To download the free PDF file, please click the link in the video description. No email needed. Visit our web shop if you want to buy the Word template for your project.
Thanks for watching. Please subscribe and see next time.